Now next topic, trigonometric functions. In this video you are going to study trigonometric functions are sum and difference of two angles and some trigonometric identities. Now trigonometric functions for sum of two angles. There is one formula, derivation of which is very important. Just very carefully try to learn derivation of this formula. First, concentrate in this figure. OX, one horizontal ray is there. Second, OY, and third line is OZ. X is the angle between OX and OY, or you can say angle X, OY is X, and angle between Y, OZ is Y. These two angles given. After this, just take in a point on ray OZ and draw perpendicular from point P on. OX is PM and PN is the perpendicular on OY. Now from point N, draw perpendicular NR and second perpendicular NQ on OX. Just concentrate here. Angle XOY is small x and angle YOZ Y. Therefore, angle XOZ, this whole angle, is X plus Y. Construction discussed. Now just concentrate on this angle. Here before it, PRN, it is a right angle triangle and this angle is 90 degree. Therefore, angle P or RPN equal to 90 minus this angle, means RNP. Since PN is perpendicular to OI, means this complete angle is 90 degree. In fact, it is also equal to RNO. And RNO equal to angle X. R in reverse order, just again concentrate once more. OX is horizontal and RN is horizontal. Therefore, X and this angle, these two angles are alternate interior angles. It implies X equal to RNO. This angle. Since this whole angle is 90 degree, therefore what remains this? 90 minus X. And if it is 90 minus X, then angle P is X. That is written in first line. This angle X is also equal to angle P. Value of angle P is X. Just two steps covered, three lines raised drawn, perpendicular drawn, and this angle P is also equal to X. Now, in right angle triangle OMP, this triangle, right angle triangle OMP, value of sine x plus y, this whole angle, value of sine theta is perpendicular upon hypotenuse, value of sine x plus y equal to perpendicular, means PM upon hypotenuse OP. In place of PM, sin x plus y equal to PM upon OP. In place of PM, write down PR plus RM. You can observe here, PM equal to PR plus RM. Write separately PR upon OP plus RM upon OP. Again equal to PR upon OP. And in place of RM, it is equal to NQ. NQ written. Now next step. Since PR upon OP written, just concentrate on PR. PR is the part of this right angle triangle, PRN. And this angle is angle P is X. For X, it is the base. The base then hypotenuse is Pn. So divide by Pn and multiply by Pn. PR upon OP we can write as PR upon Pn into Pn upon plus NQ. NQ is related with triangle NQO, in which hypotenuse is ON. It implies NQ upon OP we can write as NQ upon hypotenuse ON into ON upon OP. Then next, PR upon PN, just concentrate. PR upon PN for angle P. P is X. It is equal to cos X into Pn upon OP. Pn upon OP. Now concentrating this triangle. PNO, it is a right angle triangle. Pn is perpendicular and OP hypotenuse. Pn upon OP sin Y plus NQ upon ON. NQ upon ON in this right angle triangle. OQN, it is equal to sin X into ON upon OP. ON upon OP. Right. ON upon OP base upon hypotenuse cos Y. Therefore, first identity formula for sum of angles we can write sin X plus Y equal to sin X cos Y plus cos X sin Y. If anyone asks find the value of sin 75 degree, you don't know the value of sin 75 degree, but 75 we can write as 45 plus 30, and sin 45 plus 30 equal to sin 45 cos 30 plus cos 45 sin 30, and by putting value of sin 45 cos 30 and cos 45 sin 30 we can find the value of sin 75 degree. In this pattern there are different applications of this angle. This first identity you have covered is derivation sin X plus Y equal to sin X cos Y plus cos X sin Y. Same pattern, using same figure you can derive the formula for cos X plus Y. If you concentrate on cos X plus Y, then base upon hypotenuse. Now next, same assumption, same figure, just written cos X plus Y. Base upon hypotenuse means OM upon OP. OM write down as OQ minus MQ. Then written separately OQ upon OP minus MQ upon OP. And MQ we can write as Rn. MQ equal to Rn. In place of MQ, Rn written. Now OQ upon OP. Again same pattern. OQ. OQ is related with triangle OQN, and here hypotenuse is ON. It implies divide by ON multiplied by ON. Minus Rn. Rn is related with right angle triangle RNP, in which Pn is hypotenuse. Therefore multiply by Pn and divide by Pn. Now OQ upon ON. OQ upon ON. OQ upon ON, right angle triangle, base upon hypotenuse equal to cos X. ON upon OP. ON upon OP in this triangle, base upon hypotenuse equal to cos Y. Minus Rn upon Pn, perpendicular upon hypotenuse, concentrating triangle, sin X into sin Y. In this pattern, second identity you are getting as cos X plus Y equal to cos X cos Y minus sin X sin Y. First identity you have covered, sin X plus Y equal to sin X cos Y plus cos X sin Y. And second identity, cos X plus Y equal to cos X cos Y minus sin X sin Y. Now third, tan X plus Y. Using first and second identity, now we have to derive each and every identity. Sin x plus y we can tan x plus y we can write as sin upon cos sin x plus y upon cos x plus y. And sin x plus y is the first identity derivation you have covered. Sin x cos y plus cos x sin y upon cos x plus y we can write cos x cos y minus sin x sin y. Divide numerator and denominator by cos x cos y. Divide each and every term in RHS by cos x cos y. Here sin x cos y upon cos x cos y. Cos y cancel out. What remains here? Tan x plus cos x sin y upon cos x cos y. Cos x cancel out. Sin y upon cos y means tan y. Cos x cos y upon cos x cos y 1 minus sin x upon cos x tan x sin y upon cos y tan y. It implies tan x plus y equal to tan x plus tan y upon 1 minus tan x tan y. Now next fourth, for difference of angles sin x minus y. If sin x minus y written, sin x in place of minus y we can write it plus into minus y. Now sin x plus y formula you can apply. In place of y minus y written. If sin x plus y, you know sin x cos y plus cos x sin y. In place y write down in place of y minus y. Sin x cos minus y plus cos x sin minus y. Cos minus y in previous video I have covered. Sin minus y, cos minus y, tan minus y. These angles belongs in fourth quadrant. And fourth quadrant only cos and sec positive remaining are negative. It implies cos minus y equal to cos y and sin minus y equal to minus sin y. As written here. Therefore, put the value. You will get sin x cos y minus cos x sin y. Similarly, cos x minus y we can write cos x plus minus y. In identity of cos x plus y, in place of y write down minus y. Cos x cos minus y minus sin x sin minus y. By putting values, you are getting next identity. It means sin x minus y equal to sin x cos y minus cos x sin y, and cos x minus y equal to cos x cos y plus sin x sin y. Now next, tan x minus y. Sin x minus y upon cos x minus y. Same process as done for tan x plus y. Divide numerator and denominator by cos x cos y. The result you will get tan x minus y equal to tan x minus tan y upon 1 plus tan x tan y. First three identities you have covered are sin x plus y, cos x plus y, and tan x plus y. Next three, sin x minus y, cos x minus y, and tan x minus y. Now, next identities, sin 2x. Sin 2x we can write as sin x plus x. And sin x plus y formula you know. Sin x cos y plus cos x sin y. But in place of y, x is written here. Therefore, sin x cos x plus cos x sin x, which is equal to 2 times of sin x cos x. Sin 2x identity is here, 2 sin x cos x. If cos 2x written, same process cos x plus x. Cos x plus y already covered means cos x cos y minus sin x sin y. Cos x cos y in place of y write down x minus sin x sin y in place of y x. So cos x into cos x cos square x, sin x into sin x sin square x. Cos 2x we can write as cos square x minus sin square x. Or also in place of cos square x we can write 1 minus sin square x. 1 minus sin square x minus sin square x. 1 minus 2 sin square x. Or one more option, in place of sin square x write down 1 minus cos square x. The result you will get 2 cos square x minus 1. For cos 2x you have 3 identities. As per requirement you can apply. Cos 2x equal to cos square x minus sin square x. Second is 1 minus 2 sin square x. And third one 2 cos square x minus 1. Now tan 2x, same process, tan x plus x. Tan x plus y equal to tan x plus tan y upon 1 minus tan x into tan y in place of yx. Tan x plus tan x, 2 tan x upon 1 minus tan square x. So sin 2x, cos 2x and tan 2x. Next, sin 3x. Sin 3x we can write as sin 2x plus 6 equal to sin 2x cos x plus cos 2x sin x. Sin 2x write down as 2 sin x cos x into cos x plus in place of cos 2x write down 1 minus 2 sin square x. Next step, 2 sin x cos x into cos square x, and here open the bracket. In place of cos square x write down 1 minus sin square x. Further open the bracket. The result you will get as sin 3x equal to 3 sin x minus 4 sin cube x. Similarly for cos 3x, which you can write as cos 2x plus x, cos x plus y formula, cos x cos y minus sin x sin y, cos 2x cos x minus sin 2x sin x. Cos 2x write down formula 2 cos square x minus 1 into cos x minus sin 2x write as 2 sin x cos x into sin x. Sin x into sin x sin square x into cos x. In place of sin square x write down 1 minus cos square x. Open the bracket and rearrange, you will get cos 3x is 4 cos cube x minus 3 cos x. So sin 3x formula is 3 sin x minus 4 sin cube x, and cos 3x is 4 cos cube x minus 3 cos x. Next one, tan 3x. Tan 3x, same process, tan 2x plus x, tan x plus tan y upon 1 minus tan x tan y, same formula apply here. Tan 2x, 2 tan x upon 1 minus tan square x. 1 minus again in place of tan 2x, write down formula. Taking LCM, denominator here cancel out, and what remains 2 tan x plus tan x, 3 tan x minus tan cube x upon 1 minus 3 tan square x. That is our identity for tan 3x. And next, since sin x plus y, cos x plus y, sin x minus y, cos x minus y, these 4 identities you have covered. With the help of these 4 identities, now we are going to find next set of 4 identities. Add first and third equation, means sin x plus y plus sin x minus y. Sin x plus y plus sin x minus y. You can observe here cos x sin y cancel out. What remains? 2 sin x cos y. The next identity, which you can write as 2 sin x cos y equal to sin x plus y plus sin x minus y. If I add second and fourth, again sin x sin y cancel out. What remains? 2 cos x cos y. And the next identity, 2 cos x cos y equal to cos x plus y plus cos x minus y. Again, first 4 written. If we subtract third from first, third equation from first equation, subtract, plus minus cancel out, and cos x sin y minus minus plus cos x sin y means sin x plus y minus sin x minus y equal to 2 cos x sin y. This is third identity. And subtract second from fourth, then cos x minus y minus cos x plus y, you will get 2 sin x sin y. In this pattern, identity number 9 you are getting as 4 identities here, which we can write as 2 sin x cos y equal to sin x plus y plus sin x. X minus y. 2 cos x cos y equal to cos x plus y plus cos x minus y. 2 cos x sin y sin x plus y minus sin x minus y. And 2 sin x sin y equal to cos x minus y minus cos x plus y. If we let x plus y as c and x minus y t, what is the value of c? If you add these two, you will get value of x as c plus t by 2 and y c minus t by 2. By putting values of x plus y, x minus y, x and y, you will get next set of four identities. In place of x plus y, c, x minus y, d. In place of x, c plus d by 2 and y c minus d by 2. Next four identities we are getting here: sin c plus sin d, sin cos c plus cos t, sin c minus sin d, and cos c minus cos t. These four identities are written as sin c plus sin d equal to 2 sin c plus d by 2 into cos c minus d by 2. Cos c plus cos d, 2 cos c plus d by 2 into cos c minus d by 2. Sin c minus sin d, 2 cos c plus d by 2 into sin c minus d by 2. And cos d minus cos c equal to this result r multiplied by minus sin t will get cos c minus cos d equal to minus 2 sin c plus d by 2 into sin c minus d by 2. And next one solved question is here. You have to prove sin 3x minus sin x upon cos x minus cos 3x is equal to x. These type of questions you have to solve using identities. Usually you can think here, you apply sin c minus sin d numerator, and sin c minus sin d 2 cos c plus d by 2. 2 cos 3x plus x by 2 means 4x by 2 means cos 2x. Into sin c minus d by 2. 3x minus x, 2x by 2 means x. Upon cos x minus cos 2 minus 2 sin c plus d by 2 into sin c minus d by 2. Sin minus theta equal to minus sin theta minus minus plus sin x cancel out, cos 2x upon sin 2x equal to cot 2x, which is RHS. In this pattern you can prove and solve any question is given using different identities. Now some questions for practice. In first question you have to prove the result. You have to decide yourself which identity is suitable for you. You have to identity for sin 2x, cos 2x, or also you can apply sin c minus sin d. You have to decide and try to solve and find out RHS. Our second question is given. Here one option taking LCM you can solve. Our second option, use cos other identities as suitable for you. And third question again written. These three questions you have to solve and give the answer.